In this video, we will take a look at the slide where will we describe intramembranous ossification. The slide is stained with hematoxylin-eosin. Intramembranous ossification occurs in mesenchyma that has formed a membranous sheet and produce osseous tissue without prior cartilage formation. In this slide, you can see frontal section through the developing head in 10 weeks. You can see developing eyes here and here. The developing nasal cavity with lying epithelium. Later on, it will be pseudostratified ciliated columnar epithelium in the nasal cavity, and oral cavity here with the tongue. You can see formation of skeletal muscle fiber, which is formed by fusing of several cells. Here is Merkel's cartilage, one, and a second Merkel's cartilage, which is near of mandible. Here it's forming mandible. The mandible is formed via desmogenous or intramembranous ossification, and we will focus on this part of this slide. Mesenchyma is embryonic connective tissue which contains mesenchyma cells and extracellular matrix. For example, here is an area with mesenchyma. You can see dark nuclei of mesenchyma cells. These cells have a spindle shape or a star shape. And extracellular matrix contains a lot of fine fibers, collagenous fibers, and proteoglycans and glycoproteins. And later on, mesenchyma condenses and becomes highly vascular. Here you can see small capillaries here, and precursor cells differentiate into osteoblast. For example, here is you can see condensed mesenchyma and precursors which differentiate into osteoblasts, which begin to deposit unmineralized matrix rich in type 1 collagen called osteoid. In the hematoxylin-eosin, the osteoid is rich pink. For example, here you can see osteoid beneath the osteoblast. And also here it's osteoid, and here, and cuboidal cells or low columnar cells, it's osteoblasts, which produce osteoid. Calcium phosphate is then deposited in osteoid tissue as it is organized into bone. Bone osteoblasts are trapped in the matrix and become osteocytes. Osteocytes you can see here, and the dark tissue is mineralized bone matrix, and osteocytes is inside the bone matrix. Osteocytes are spider-shaped cells reside in small spaces called lacune, and are connected with neighboring osteocyte by slender processes that lie in small channels called canaliculi. Osteoblasts are themselves on trabecular surfaces and continue to produce bone matrix. So here you can see osteoblasts, also here, and here you can see a line of osteoblasts, similar of cuboidal epithelium. Osteoclasts are large multinucleated cells, for example here, and these cells found in at sites where bone is being removed. They rest directly on the bone tissue where resorption is taking place. As a result of osteoclast activity, shallow bay called a resorption bay or Hopship's lacune can be observed in the bone directly near under the osteoclast. Here it's Hopship's lacune and multinucleated osteoclasts. Osteoclasts are multinucleated cell with hematopoietic origin. Yes, you can see 1, 2, 3, 4, 5, maybe 6 nuclei inside the osteoclast, and beneath the osteoclast is a Hopship's lacune. Osteoclast resorbs bone tissue or bone matrix, and osteoblast produce the bone matrix. Here you can see another osteoclast. Here. So, and here is also osteoclast, which absorb the bone matrix. Hormones and cytokines regulate remodeling of bone by the coordinated activity action of osteoclasts and osteoblasts. So this is one side, and another side you can see also osteoblasts, which cover the bone trabecule. Beneath the osteoblast is osteoid, very rich pink. The osteoid is unmineralized bone tissue, and the darker purple is mineralized bone tissue. Osteocytes are trapped in bone matrix, and last type of cells is osteoclast, but not here, it's not visible. I show you here, for example, osteoclast and another osteoclast. So thank you very much for your attention.